It's the middle of the night, and your app is throwing the same error over and over. Temporary failure in name resolution. But here is the strange part. The database is running perfectly. Nobody deployed anything, and every alert points at a server that looks completely healthy. By the end of this case, you will know exactly what that error means and the two small things that quietly cause it. Let's dig in. Quick question before we touch anything. You can reach the server by its IP address, but the moment you use its name, everything breaks. So where does the problem actually lie? Pause if you need to, lock one in. We will prove the answer together. Rule 1. Never debug from a screenshot. Let's read what the app itself is saying. Journalctl is the systemd logbook. -u picks one service, and there it is twice. The database. Temporary failure in name resolution. The cache. Connection refused. Two different errors from one app. Hold that thought, it matters later. Now the test that splits the whole case in two. Can we reach the backend at all? Curl fetches a page from the command line. We hit the backend by its raw address, the loopback, no name involved. 200 OK. It's alive and answering. So the machine, the network, the service, all fine. Same backend, same machine, same second. But this time we ask for it by name, could not resolve host. Nothing changed except the address versus the name, so this was never the network. The box simply cannot turn the name into an address. That is name resolution. That is DNS. Let's picture the whole journey because it is simpler than it sounds. Your app has a name, it needs an address, so it asks Linux to look it up. Linux follows one rulebook called NS-switch, and the easiest way to picture it is your phone's contacts. When you call a name, your phone checks its own saved contacts first. Only if the name is not there does it ask the wider network. Linux does exactly that. First it checks its own little contact list, the hosts file. Then it asks DNS, the name servers out on the network. Whichever one answers first wins, and you get back an address. That's the whole thing. So when name resolution breaks, it breaks in exactly one of those two places. Remember that. The entire case lives right here. Before we hunt, two flashlights. Getent, then hosts, then a name, asks the question exactly the way your app does, through the rulebook. Hosts file first, then DNS. It shows what the system actually resolves. Dig is different. Dig talks straight to a name server you choose and skips the rulebook entirely. So Dig never even looks at the host's file. Keep that gap in mind. The difference between these two tools is what cracks this whole case open. We know names go to DNS, so which name server are we even asking? This one little file holds the answer. One line, name server, then an address. That is the only DNS server this box will talk to. Now let's test the resolver that should be answering, the internal one running right here on this machine. We point Dig straight at it, and it answers instantly with the correct address. So the real resolver is alive, and it knows our database. The problem is the box was told to ask a completely different server, a dead one. So we point it at the resolver that actually works. T writes our one line into the file and prints it back so we can see it. A quick note from a senior, though. On a real server, something like Network Manager often rewrites this file, so the lasting fix lives in its config. This stops the bleeding right now. Moment of truth, the way the system itself sees it. Getent, and the database name resolves to the right address. Layer 2, solved. And by name, straight through the front door. Backend, okay. The database is reachable again, one service back. But remember those two errors at the very start. So DNS is healthy now, the database is back. But the cache, that second error from the start, is still down. And here is what drives engineers crazy. DNS is working. We just proved it. So why is one single name still going to the wrong place? Let's ask the system about the cache the exact way the app does. Getent, and here's the twist. It resolves. No error this time, but to an address that is just wrong. An old one. So DNS is healthy, and yet this name still comes back wrong. Something is overriding DNS. And we can feel the difference. By name, the cache refuses every connection. Could not resolve like before. This time it resolves just fine to an address where nothing is listening. A completely different failure. Connection refused. Time to check the one thing on this box that can beat DNS. The host's file. Read the bottom line slowly. Somebody pinned the cache's name to a hard-coded address. Think of it as a wrong number saved in your contacts. Your phone will trust it over the real directory every single time. Probably a quick fix during some incident a long time ago, and nobody ever took it back out. And here is why that single line wins. The rulebook again: hosts, files, then DNS, files first. The host's file gets checked before DNS even gets a turn. So that stale line silently beats the correct answer every single time. Burn this one line into memory. It is sitting on every Linux box you will ever touch. Files means the local host's file. Think of it as your phone's own saved contacts. It is checked first, fast and absolute. If the name is in there, the search just stops, and DNS never even gets a turn. DNS is only consulted if the host's file had nothing to say. So an entry in the host's file doesn't just compete with DNS, it overrules it, which makes a forgotten host's entry one of the most confusing bugs in Linux. DNS looks perfect. The answer is still wrong. Now you know exactly where to look. And if an interviewer ever asks why a name resolves, but to the wrong address, this single line is your answer. Let's remove that one line. grep-v means, give me every line except the ones that match. So, every line except the ghost. We save that into a new file, then copy it back over the original. One careful edit, and the stale line is gone. Ask the system one more time. Getent. And now, with the host's file out of the way, the question finally falls through to DNS. The cache resolves to the right address. And the only test that truly counts. By name, through the front door. Backend, okay. The cache is back, both services healthy. Now let's lock in what this incident taught you. Playbook: if the address works but the name fails, stop guessing. It is name resolution, not the network. Use both flashlights. Getent shows what the system sees. Dig asks DNS directly. When the two disagree, the host's file is hiding something. Check the resolv.conf. Is the box even asking a name server that is alive? Then check the host's file. One forgotten line in there silently overrules perfect DNS. And fix the real source, the thing that rewrote it, not just the symptom. Or it comes right back on the next reboot. Here is what the senior writes up afterwards. One symptom, temporary failure in name resolution, was sitting on two completely separate causes. The resolver config pointed at a server that was dead. And underneath that, a stale line in the host's file was quietly overriding DNS for one name. The lesson that lands in interviews. Name resolution is not one thing. It is a chain. Files, then DNS. Your own contacts, then the directory. So when a name misbehaves, you don't guess. You walk the chain, get ent and dig in hand, and the layer that is lying gives itself up. That, in an interview, is the difference between a junior and a senior. Case 3 closed. If walking that chain made DNS finally feel simple, subscribe, because the next one is a creepy case. There's a process running on this server. It looks like a normal system process, but nobody installed it. See you in the next one.